Hello everybody, welcome. Howdy. I'm just going to check my sound, make sure it's the right level because we don't want it going over 9,000. I think that looks good. We're only in the orange. Get the gain down slightly. Okay, hello. We're looking, let me just get this. I don't want that. It would be nice if this interface between different screens worked. Alright, here we go. Now I can see the chat, that's really important. And just like last time, we're looking at calculator papers today. So this is a paper I've made myself. It's, you won't get it anywhere else. It's unique and up for grabs, right? So just a quick tour and tell you where you can get it. This can be found on a website called Patreon. And on Patreon, I have a number of resources and live streams that are exclusive, and you can take part, you can request a number of things. It'd be great to see you over there, but even on the smallest tier, you can get hold of all of the materials. And it's only a small amount, so hopefully that helps. But I'm going to take you through a lot of this today. It's just you can access the rest of it on Patreon, and you can also get this a couple of days in advance of the live stream, so you can have a go at it. So quickly going through the questions. Yeah, you can see we've got a number of them in here. We've already done some of these from the other day, and we're going to be starting here today. So it's looking at the number of, the questions that have already been on paper 2. Typically you're not going to get tested twice on the same thing. That wouldn't be a very good design. And so it has to be something different. Now the topics, you may think, let's say quadratics is very broad. It's come up once maybe, so it might not come up again. And that's not necessarily true, because as you understand, there's many different things about quadratics. And so what aspect of quadratics has not yet come up? So these are the kind of things I've been trying to think of. And as you can appreciate, I only knew about this since yesterday, 6 p.m. So with regards to these questions, they've had a quick turnaround. And I've managed to produce a good amount for us to go through today. And hopefully we can get a number of you online. If not, don't worry. This is perfect. It's like creating a video for myself. You can watch the replay. Okay, so let's get started. The first question on here you've probably seen already. It's definitely not come up so far. So the reason that it's here is just to fill in those gaps, to make sure that we're okay. I don't know a year where it's not come up, right? So it's definitely worth looking at. I'm just going to check the streams up and running from a third party point of view, and then we'll get going. Okay, have a go at this question for now. I think it is. All right, let's just put this here. Well, what is 6:30? 6:30 may be something like dinner time. It could be something like I'm revising something else right now. Hopefully my decibels are not too bad. It seems to hit the top. I don't know if it would be too loud. It will go into the red. You just let me know if it's too loud, okay? If you're watching on a replay, nothing I could do about it. All right, let's get going. So question 15, asking us to simplify this. Is something maybe confusing? The word simplify here, like, okay, it's already simplified. There's nothing I can divide the top and the bottom by. But as you'll notice, the bottom here is something that we call a rational. And this is an indicator that it's not simplified. In mathematics, something that is simplified has a rational denominator. You may continue to ask why, of course, for a number of different things, mainly because when a denominator is simplified, it's easy to work with. We can combine it with things. So we're looking at a conjugate here. That's how this works. To get rid of this irrational part, you can't just multiply it by a number. If I multiplied it by 2, that's 2 root 2. That's not going to get rid of it. If I multiply it by an irrational number, let's say root 2, I have 3 root 2, and you can see the issue now. You've changed the root 2 to 2. Okay, so let's just write what we did. If you times it by root 2, you've got rid of the irrational part on the right, but then you create another one here. So it requires a very special format. So you might, in the exam, get something really basic like root 7, right? I'm not saying it is. I don't know the exam. But in this case, it would work. Wrong subject. It would work if you multiply by root 7, top and bottom. That would leave you with 7 and root 7 on top. Yes, well, I know it's still on the numerator. Okay, that's okay. The whole point is to get it on, to get it rational on the denominator. So it doesn't matter if it's irrational up there anymore. Why did I go over that one? Because this may not be the one you get. This is an example of a fairly hard one, I would say, at this level. So let's have a look. I guess we've got to be really careful here. One common error that people make is they do this. Okay, so they're multiplying by the same thing. Another error that they make is they'll do it up here as well. Right, so it's actually the conjugate of the denominator. Okay, like that. Multiplying the numerator and the denominator. Okay, so in this regard, we have to be very careful with the denominator. This is no joke. At GCSE level 2, when we're expanding, you may well get away with it if they are numbers, whole integers. Fractions, yes, but when they're surds, a little bit of magic happens where things seemingly disappear, like they cancel to be 1. So really what you want is to be doing this properly with the support of a particular method, and it doesn't have to be a box. For me and many people, a box is what works. I'm just going to test that this, yeah, so let's go through and fill this out. Multiplying those two, we've got 9 and 3 root 2. And on the bottom here, negative 3 root 2, really good. And then how do we deal with this? Well, whenever a negative's out front, this is like, it might be obvious to you and good for you, carry on. If it's not, this is one way of thinking about it. Okay, so the negative out the front actually means negative 1 multiplied by root 2. And then that's multiplied by root 2. So in essence, they're all being multiplied. So let's focus on the two that interact well. That's the 2 square roots. So that's negative 1 multiplied by, and the result of this is 2. So we get negative 2. Another way of thinking about it is just focus on these square roots, which is 2, and then add the negative back at the end. But if you're ever stuck, you need to write it out in first principles like this. You know, what's really going on? What are the operations in between? And it's not worth getting it wrong. Okay, so these like terms we can see in the diagonal are going to cancel. So when we're doing this method, technically we're multiplying one side by another to find an area of a rectangle. Every multiplication in maths is finding an area. And you can represent that area diagrammatically. You can draw it. In this case, it's the little box we've filled out. And an area means it's this whole surface. So we have to add all of these 4 bits together. So that's the impetus for why we do it. Adding this one with this one, we get a 0. So that leaves us with a 2. Fab. Okay, so we've got rid of some of the misconceptions and the problems already. The like terms, the fact that we are using negative is the same thing, but with a negative. 3 plus and 3 subtract. We can't go too far wrong if we're, got structure like this. So overall, that bottom, the denominator multiplication is 7. So we get into our answer here. At the bottom we have 7. And on the top we've got 1 multiplied by what that is. So 3 subtract root 2. And as you can see, the bottom number there is rational. Okay, rational because it can be expressed as a fraction. Rational because it's not a decimal that goes on forever without a pattern. Okay, so this is simplified. Simplified without the rational, so without the irrational denominator. Okay, looking at question 16 now. So that's the first one that hasn't come up quite yet. Give you a bit of time to do it yourself. That's always important, I think. I've chosen to make these questions as they are, but it's possible to engineer them more towards the calculator end. This is more showing that you know the rules, so it's not necessarily something that you can do on a calculator. I mean, everyone could do 2 subtract 4 over 3, but you've got to know that that's what you have to do in this scenario, the way that it's set up. So in essence, we can split these 2 fractions as such. Okay, and remember, having a calculator there, it's always good to double check your work. I personally probably don't do it as much as I should. It's a bit pedantic. There's a lot of merit to doing it in your head, but always double check in exams. So this first one, as you can see, is 4 over 3, because it's to do with the 7 times table. You can see that there are 3 7s in 21 and 4 7s in 28. And over here on the right, what are we doing when we're dividing a particular same base? We are subtracting the indices. So in essence, our sum is 2 subtract 4 over 3, which you can do with a calculator, of course. We can do it by hand as well. It's always good to see those methods. It helps when we do it by hand, like in our mind. It really allows us to be able to work with algebra, because you can't put algebra in your calculator, and the same things we do with numbers we do with algebra. So it's really good to find some methods. So if I want the same denominator 3, what would I divide by 3 to get 2? Hopefully you can see that's 6. At this point it seems fairly straightforward, doesn't it? There you go. Don't like that one. Shouldn't be touching it, huh? Okay, so now we have, we've got this, and nothing really much more to say about this, except these sort of rules are most definitely in a calculator paper, and just be aware that they may come up. You never know. And if they don't, this skill is in part of a different question. All right, next one. Find the set of values for which this is true. Now, this is here not so much as a question. This could be in a number of different things, but the set of values can be found, and I wanted to do this here to show how to do it on a calculator if you have one, and then how to do it if you unfortunately don't have a fantastic whizzy scientific calculator. So if you have a whizzy calculator like the FX991EX, FX991EX, like this, and then you go to menu, and because this is a quadratic inequality, like there, it's an inequality, and it's quadratic because we have the squared there. What we're going to be doing is go into the inequality section on the calculator, which is section B. If we click on that, it asks us the polynomial degree. And this is a degree 2. I'm going to point to it again. The squared means degree 2. And we get 4 options. The 4 options don't look anything like our options here. The 4 options are like a range of things like this. Bx plus c is more than 0. Well, it's hard, isn't it, to think about that. What I would say is that the inequality is open towards the quadratic, okay, with the 0 on the other side. And the inequality is singular. So what we're looking for, and I'll write down the 2 options. So out of these 2, which one are we picking? You can see that it's open towards the 0, so we're going to have to pick this option. Even though our quadratic is in the form c plus bx plus ax squared, we should still be confident that it's quadratic versus 0 and the inequality goes this way. Okay, so we go for this option, which is 2, and we type in the coefficients. So we have to be careful here again that actually this is more written the other way around. So negative 2x squared, negative 5x, and plus 3, like that. So it's actually negative 2, and then equals, negative 5 equals, and 3. When we press enter one more time, what comes up is this. X is less than negative 3, comma, half is less than x. Now, that's all very well. I think you do have to know what's going on, though, okay? So we've got x. I mean, you could write that. You can write that. We've got x squared, sort of quadratic, and we need to be able to know what the key points of this quadratic are. The key points are these numbers here. This is where something significant is happening. Now, if I factorize this, and I'll just take through it here. 2 times 3 is 6, so we're looking at 3 and 2. So we've got 3, take away 3x, take away 2x minus 2x squared. We're splitting the x in the center into a couple of factors that are factors of the product of 3 and 2, which are the c term and the a term. So you've probably heard this method. And then we're going to factorize. Yep. Negative 2x, 1 minus x. And then we factorize again. So we've got 1 minus x in both. Now, just bear in mind all of these were less than 0, and that's still true for down here. So we're looking at this quadratic and when it's less than 0. We first of all figure out that we have, let's do it properly actually. We want to find a root. This equation is 1 minus x equals 0, so x equals 1, and 3 minus 2x equals 0, so let's do it this way around, x equals 3 over 2. So we've got our couple of things there. And let's get some space here. Yep, there we go. Right, so basically this quadratic here, if we draw it, I'll just double check that this does expand to be that, because I feel like it's a different thing, but I'll do it. Always double check if you're not sure. So negative 3x minus 2x and then plus 2x squared. Yes, that is what happened there then. It's okay, we'll double check this. Oh, there we go. That's plus. So actually we take out a plus 2x, don't we? So we take out a plus 2x. Yeah, but that doesn't work. That doesn't work. Very interesting. Why that's not that method. I just thought I'd take it through there, and it's clearly being a pain. All right, what we'll do is we'll start here back. I thought it'd be straightforward to just I'll keep that graph there for drawing, and we'll look to solve this polynomially. So we've got -2, -5, and 3. Yeah, half and -3. That makes sense. I'll just start again. It might have been something -5x plus 3. Okay. Yeah. I mean, to be honest, we could flip this to the other side to make it easier in a way. I probably am going to do that. So if everything here went to the other side, it would change like this, in which case it would be that way around. Yeah, because it would be towards the quadratic, which would be there. So let's see what went wrong there. 2 times 3 is 6. And so I'm thinking 2 times 3. Oh, that's what went wrong. So when you're doing these quadratics, and who knows if it's a generalized version that you have to do, these particular ones have 2 options, and it might be that the 2 and the 3 seem to work, but they don't. That should be a 6 and 1. Perhaps it's the 6 and the 1 that we need to go for. So I'm just going to try 6 and 1 this time. So yeah, 2x squared, 6 and 1. Oof, hard to go, but I'll just say this is plus x. It's not plus x, is it? It's minus x. Because we want plus 6x over this side. I think I want it over there. I'm now thinking I might want the negative with a negative, because it doesn't matter which way around it goes, basically. So we'll keep it like this, and we'll see if that works for us. Okay, and 2 comes out, x comes out, x plus 3. Yeah, and then we're going to subtract x plus 3. All right, now that's actually a good sign that we have that, because when we have the same bracket, that's probably a good indicator. 2x minus 1 and x plus 3. All right, it's looking more promising. So 2x minus 1 equals 0. We've got x equals a half. And then x plus 3 equals 0. We have x equals -3. So those are our 2 roots. So we can plot them roughly on here. That's a 3, trust me. It's just the sensitivity. X equals a half, like here. And you notice I'm not being too worried about where I plot these. It's just a sketch, okay? And we have a quadratic now, which is a positive quadratic, which is slightly different from where we began. We began life, it was a negative version of this. In this case, something like that. And our 2 different roots, perhaps, in the same position, they would be indicating more than or less than in a different way, because the graph is flipped. So how do we deal with this then? So we're saying, when is our graph? Remember, this is the one that we've changed it to. When is our graph, which is this left-hand side bit, more than 0? And what do we mean more than? We mean the y. So when is the output, it's a bit too far at the edge there, in other words, the y, more than 0. Now the y is this axis here, right? The y-axis. is the height. It's the horizontal height as we go up. So clearly there are some places, let's use a different color. There are some places where the height is definitely below 0. Okay, so that's all the way across this range. But these represent really important points, because as soon as we get to those, we suddenly have a y value that is above. In fact, I'm going to use a different color. Green. Green is very far removed. We suddenly have y values which are above 0, and that's what we're after. So how would we define those points? We would say x is less than -3. That's this one here. So everything past that point. If you're wondering what this inequality symbol is, like, you have to do it based on this scenario. So if we want less than -3, but if you're wondering why it's not or equal to, it's because we match what's in the question. And over here, we have x is more than a half. Okay, and there's a union between those results because it's both of them. Or you could, as it does on the calculator, write a comma like this. Depends if they want you to do set notation, right? So yeah, we'll leave it at that. That's how you do it without a calculator. But I wanted to go through this because, as you can see, the format can be causing problems, and feel free to rearrange it to how you want it to, and don't be shocked if you don't see that in like your calculator, because they know you've got a calculator. They know you've got a fancy one. They now know about the FX991 and all of it does. So, they won't make it like, they will give you 3 marks for something a calculator will do instantly. So just be aware of that. Okay, moving on from that. Lovely reminder. Probability has not come up yet, as far as I'm aware. The tree diagram situation might come up in a very horrible way. So remember one year we had Hannah's Sweets. I've made a question which is quite similar to Hannah's Sweets, so let's dive into it. A bag contains 3 green and n red balls. Okay, it's time for a change of pen color in honor of this question. So a bag contains 3 green and n red balls. A ball is drawn at random from the bag. Its color is noted, and then it's put back into the bag. As we're all screaming at the screen here, this means that it is not conditional probability. Write down an expression in terms of n for the probability of drawing a green ball. I know there would be some people in here tempted to draw a tree diagram because they see this situation with a bag of balls, and you're thinking, let's go to autopilot. Really, it's not needed here, and I don't see a need to draw during this question, but we'll see. An expression for the probability of drawing a green ball. So it's simply the probability of drawing a green ball. So the 2 things that we need for this probability. We need a total, like how many there are in total, and then we need the number of green. So we'll call it number of green in the place. So we can get expressions for them. The number of green balls, well, actually that's 3. And the number in total that's in this bag is going to be those 2 entities added together. So we'll say n plus 3. And this is the probability of getting green. Fairly simple. It's general. It's not whole numbers like obviously people would prefer that, but it is what it is. Okay. Let's have a quick look. Nobody's online. Very sad. It's okay. As I said, I'm making this video for anyone who, this isn't your day for doing maths. You can come back at any time and go through these extra questions. Now, if that's the case, you probably want to pause the video before I go on ahead and do this. And if there isn't anyone here asking questions, what I'll probably do is simply carry on and allow you to pause when necessary. After a ball is drawn out and replaced back into the bag, a second ball is drawn out. So that's important, replacement. Given that the probability of drawing balls with different colors is 4/9, prove that this is true. And this is like Hannah's sweets question. You're like, what? So how do we do it? I'm personally of the, I guess I've got so far to this that I don't need to draw a diagram, but you totally could. You've got the possibility of it being, what colors are we doing now? Green and red, because you couldn't pair up blue. Or a number of other things. Green and red. Green and red. And the same again. So you can go ahead and draw the diagram like this if it gives you a sense of what's going on. For your purposes, for you to see it, that's fine. I will just quickly draw it now. This scenario gives us green, green. This scenario gives us green, red. This one's red, green. And this one's red, red. So as you can see, we're looking to find where they're different. And they're different in the middle, right? So where we have GR and RG. So I have a particular layout here that I'm going to use. I'm just going to get rid of all of this and start with the working out that I would do. So firstly, the probability of getting a green red, so it's a green and a red. This actually represents a multiplication, okay? So 3 over n plus 3 is the probability of getting a green the first time. We've already done that one. And then the probability that the second one is red, well, they put the ball back in. So the scenario is no different. It's just n number of reds in there and still a total of 3. So this is a probability of green and then red. Should probably simplify it. And it's really good at this stage to recognize that n plus 3 is the same thing here. So let's square it. Right, let's on to the next one. Probability of red and then a green. It looks like the same values are coming up. So there's n reds. I'm going to put that red one back in, and then there's the same as before. There are 3 greens, and in total, it's still the same. So looking at that, very interestingly, they're all the same. Same as the one up there. So if we're talking about the probability up here of drawing 2 balls of different colors, these are the 2 scenarios where they're different. This one or this one. And hopefully this should trigger your thinking that, like, the addition. Okay, so we're going to add these together. But if we're going to add the same thing, we may as well just multiply it by 2. So 2 times this, and I'll just got to write it as it is, 6n over n plus 3 squared. Okay, so 2 times, you're going to multiply the numerator there. That's where the 6 comes from. So this is the probability that they're different colors. And it says here that it's equal to 4 over 9. It's very good. Now that's our premise. That's like a fact now. This is really useful. We've got an equation because we have the equal sign. We've got some quadratic elements, and now we just have to prove that this is true. We probably already have by the existence of this, but we have to get there. Okay, that's what proof is all about. So we're going to have to do some sort of cross multiplication. So 9's going to come up. Let's just do it explicitly for you. 9 times 6n. That's going to multiply both sides. Okay, and then the n plus 3 is going to go up like that. And if we do some expansion, n squared plus 6n plus 9. Okay, so a little bit of rearrangement is what we need here. If we move this over, we're going to get 4n squared minus 30n plus 36. At this point, it's worth looking where we're aiming, right? Are we in the right direction? We do need 2n squared and not 4n squared, so I think what we're doing here is we're going to divide the whole thing by 2. And I'm just going to take my phone off of vibrate. Thanks, phone. Divide by 2. 0 equals 2n squared minus 15n plus 86. I meant 18. And all right, so this is what we wanted to find. If you do a proof and you find it, you can write QED at the end. And it means proof as you wanted, as required. There you have it. So here, in this instance, this could be useful later. It represents, what does it represent? Well, n is the number of, let's go back up, red balls. And so this represents the possibility, the existence of the number of red balls. Bearing in mind that it can only be a whole number, right? Because there's a ball or there's not. There's not half a ball, otherwise it's not a ball in the bag. It sounds kind of strange, but it's true. So we're looking for whole value solutions of this. So now we know it represents the number of red balls in the bag possible. Show that the bag contains 9 balls in total. Well, in order to show the total as a single number, what's stopping us is the value of n. And we have an expression here that could help us, that could solve it, right? So we need to solve it using our calculator, because we've got a calculator paper. So we go to menu and then equations. So I'll give you a second there. So menu and equations is like A. So you're going to have to go down to, and then like the reference is A. And then you've got simultaneous equation versus polynomial. I've got YouTube videos on this actually. So you should probably go and check them out for more practice. We go to polynomial and 2 degrees. And we're putting in 2 for A. Thankfully, it's in the right order. Negative 15. If it's not, you know what to do. Why would you? You know what? If that came up, the scan guard. I don't know if you saw that on the live stream, but oh my goodness, it's so intrusive. I unsubscribed from it, scan guard, and it's so annoying. I've deleted it, and it's like you should buy me again. And I swear, guys, I didn't get a virus for years. I didn't do anything dodgy, and it's the moment I uninstalled it, and like, what else did I do? I deactivated the account. I got a virus warning. Oh, we saved you from this virus. You need us back. We just helped you that one time. It's a bit sus. Not gonna lie. Where are we at? So we're solving this using the calculator because we're on a calculator paper, right? So what do we get? A calculator churns out for us that x1 equals 6 and x2 equals 3 over 2. But why do you get 2 marks for that? Because we need to discount the fact that this is not possible. And if n plus 3 equals the total, and n equals 6, because that's how we just found it to be, therefore, total is, should we do it that way? Yeah, 6 plus 3, which equals 9. Call me over the top, but there's a lot of work for that. And absolutely. Oh, we have some chat. Hey, hello, HA. I'm doing these lives a bit earlier now because I don't know. I saw some other people going online at 7:30. I thought I don't want to be a competition there. I don't want to force people to choose. But yeah, if it's too early for you, I'm very sorry. What about the quadratic formula? Yeah, that has not come up yet. And there's no reason why we can't do the quadratic formula now just once, because I mean, why would the quadratic formula come up? Probably because when you're putting the numbers in, they're not very nice. So the quadratic formula comes up in the non-calculator with thirds and exact values and stuff, but it might not be nice. And in this situation, it's not that nice. It's fairly hard to solve this by factorizing, but you totally could. So one over 2a. You totally do it this way. The numbers are fairly large. As I said in my video, I think for the purposes of this live, I'm just going to say go to my video for it, but put the 4ac in brackets. That's going to be 4 times 2 times 18, because this may end up being a negative number, and it's really good to make clear how it interacts with the negative on the outside. But look at the quadratic videos on them if you want a quick revision. It's I set it out very clearly in a way that you won't make mistakes. Could the quadratic formula come up? Do you know what? If things like that come up, I would say they're going to be asking you to do some sort of proof. So the calculator is not an advantage to you, yeah? So prove, no, they would never do that. I was going to say prove the quadratic formula. So you'd have to start from a generalized form of the complete the square. But no, I don't think they would ever do that. If you do want to prove the quadratic formula, there's so many ways of doing it, but this here is a solution, right? When the function equals 0, there are your solutions. Technically, you want to factorize, because when it's equal to 0, factorizing allows you to see two numbers multiplied together. If you set each of them equal to 0, they're going to give you a solution for what you're aiming for, right? A 0. So this is the whole purpose. And if you complete the square is another way of doing that. So if you complete the square on this, you will find the quadratic formula. So whenever you've got a quadratic that has a number which is more than 1 out the front, you can't just assume it's 1. You have to take into account what you would do with it. And you would factorize it out first. All right? So x squared. And when you factorize out, you take it for granted, but it's actually a division. So you're going to divide by a to get it out. Now, I'm not saying there's not other ways of doing this. There's loads of ways. Your aim is to get x on its own, right? That's what you want. X equals something. When you complete the square, it's really good because, as you remember, you're going to get rid of a number of x's when you put it into this new bracket. So half of the b over a is b over 2a squared, and then subtract b squared over, in fact, should we do it all squared? b over 2a all squared, like that. So I'm not going to go the whole way, but now you can see there's only one x. So your job at the end is to just get x alone. This is the example of a question where it's clearly using a quadratic formula or methods of quadratics, but the calculator is not going to give you an advantage. So it could be something like that. Shall we finish our question? Find the probability of drawing 2 green balls in a row without replacing between each draw. So in this case, it's conditional probability. We just need to be careful. I'm not going to draw a tree diagram. I don't find it necessary. Please do if you want to. Green the first time. Now we know that there's 9 in total. It's out of 9. Just going to remind myself, there were 3 green balls to begin with. And we don't replace it. So this is the next event. So if it's this and the next event is a multiply in between, green again, well, if green was the first selection, then there's 1 less. And then that means there's 1 less overall. We'll just multiply across. 6 over 72. 72, 612. There you go. 2 green balls is a single particular scenario. There's no other way of looking at that. All right, so that's conditional probability. Only because I don't think this has come up yet. And this is a really fine example of how nasty it could get. And quadratics haven't really come up yet either. So I thought probability and quadratics. Would they do that again? I don't know. They've got a precedent for it with Hannah's Sweets. So if you do want another question like this and you've never seen it before, go and check out Hannah's Sweets question, pause the video and ensure that you don't cheat and see if you can do it. It's very similar to this sort of thing. Okay, there we go. What's this? This is something that's not come up yet. And I thought it's one of those formats I don't think many people know how to deal with this. So variable m is directly proportional to variable s and inversely proportional to another variable t. Like that. If we were to turn this into a formula, something like this. So this is like when they are proportional in the same way, you've got 2 things. I don't think this often comes up, but let's just say that it does. In the same way, you've got equals, and then you're multiplying by some k term, okay? What we're going to do is, well, that's your hard part out of the way. We're going to look at this, which is a condition. Okay, when you get older and you study this at a higher level, this is a boundary condition. It allows us to find things. Okay, so we've got 1 unknown. It will allow us to find k. So m is a half. K multiplied by s is 3. And all over t is 60. So all implies that k, 30 divided by 3 is 10. Okay, so we found k. That means that we can rewrite the formula. Do we want it there? No, we don't. We want it up here. We can rewrite the formula to get the constant term involved. So there's clearly 2 things going on here. And we'll use our calculator because these numbers are not the best. So the final question of the matter is find the value of m when we have these as a condition. So that's going to be m is 10 times 4.27 all over 8.02. Okay, putting stuff into calculators. Open up a fraction. It's the first thing to do. It looks like this. We're going to press that button. And then we're going to fill out the top, right? So 10 times 4.27, 8.08. Press equals. Doesn't matter where you are. Alright, as a fraction, it's this. Press the S to D button, and then you get the decimal. It doesn't say what they want it here. I say they, but I wrote these questions. I should probably add that. Something sensible is... Actually, I'll tell you what. The best thing to do is write what's easy for you. Which is 5.3, and just say 1 decimal place. It's very reasonable to give it to 1 decimal place here. If you don't have the S to D button because you're rocking the new CW calculator, you're going to have to press the format button, something like this, where you got arrows. Right, they're all circle buttons, right? And you go down 1 and then click on decimal. And then you will get your version there. What's the point here? Well, the point is that this little bit at the beginning is setting up a proportional relationship, and you can't do that on a calculator. So this is something, if it's not come up, it probably will. I think everything, there's not a year that it hasn't. You know, I'm happy to be surprised. And I wouldn't bet more than £1 million on it, but that's good. Good job I don't have £1 million. But this is not calculator. Then it's using numbers that perhaps do need a calculator. I wonder if you could make this entirely algebraic. Might be a good question to develop in the future. All right, many parts to this question, and each one worth quite a lot of marks. You'll be surprised. All right, what's this then? How can I get it so you can see it? Probably best here. So this is a cup. Yes, it is. And the cup has got, this here is juice. We'll read it. Let's read the question. This here is a party piece. Okay, so a party piece, sometimes they have little trees that they put into the drinks, or sometimes it's got a little shape at the top. In fact, just for fun, sometimes it's a 4-leaf clover, you know, party thing to put in your drink, or a flamingo. How do you draw a flamingo? Something like that. I don't know. What's a flamingo tail? Does it go down? Anyway, it's one of those things that you put in a drink, okay? And it's 18 centimeters. And this cup has a radius of 3.98 centimeters. Bear that in mind. Give you some time, well, no, I don't need to. No one's here live, so I can just let you read that. Pause the video at this point. The cylindrical cup is mostly full, with 771, let's write that down while we don't forget it, 771 milliliters of elderflower spritzer, I could do with that right now. Elderflower spritzer, yeah, elderflower juice in with just fizzy water. Summertime. The radius of the cup is 3.98 centimeters, a thin decorative party piece. That's this. See how I put a little texture on it, like decorative. Is the best I could do. Is to be placed inside the cup. Okay, so what does that look like? It's going to be put boing in there. Does it just stay there? No, it like tilts to one side, doesn't it? So try and get your imagination going there. The party piece has a length of 18 centimeters. You see it's reasonably thin. You would call this a thin rod in mechanics. It's something that doesn't really have a width. So there are limits and assumptions here that this doesn't have a width or anything. Okay, so that's the limits of maths when we're applying it to real world stuff. Will the straw be completely covered by the drink in the cup? Why has I said straw? It's not a straw. I'm calling it a party piece. Everybody, a party piece. Right. I think, look, here's some insight. Everyone cares. This used to be a straw, and I think there's too many assumptions that people get annoyed with, so I turned it into a stick. And then I thought I'd turn it into a party piece because it's more interesting. It's not exactly the most fabulous party piece. Let's call it diamonds inside the center. So tiniest little diamonds, no width. Moving on. It's hard, isn't it? Maths in real life. You must give a fully justified reason for your answer as to whether it will fit into the cup. So you might have some thoughts on this. You don't really know much about the cup, right? It would be really nice to know the height of the water. That would be super duper. I'm just checking the live here because it says there's an error, but it doesn't seem to be on the phone. I'm just going to keep going. Okay, so what are your thoughts? We've got a straw that goes in. If you think about the straw at its a party piece, and it goes in straight up. We don't really know how tall this thing is to say whether it's going to fit in, right? So the first thing is to use the information that we've got to try and find this height. And what we do know is that, if we take it down to the water level, that this has also got the same radius clearly as the cup at the top. So we have a cylinder of water. And this cylinder of water has 771 milliliters. This has a conversion. So a milliliter is a direct conversion into centimeters cubed. I don't know if you knew that, but that's really a useful thing. So we have a volume already. Okay, so this is 771 centimeters cubed. And in relation to our diameter there, we could find something useful. Okay, so this expression for a cylinder would be pi r squared multiplied by the height. And this is our height in this case. And that's the volume of the whole thing. And that we know is equal to 771. Okay, so h in this regard is 771 divided by the pi r squared. So that's pi times the radius, which is 3.98 squared. Okay, this is where we put it in a calculator. Okay, just be careful with the brackets. So definitely put it in brackets as I've done here. So open up your fraction, calculator, brackets, etc. All right, you probably paused the video, and I just going to keep going. So on my calculator, whilst I was talking away, I got 15.4931, etc. I'm going to keep it in my calculator, and what I'm going to write down is a reasonable amount of digits with a few dots. Okay, so let's get rid of this, because this is the kind of thing that's going on in your head, right? So we've got h, 15.4931. Question is, will this straw fit into here? Now clearly we're looking at the height as 15 and the 18 and thinking, no, 18 is obviously bigger. But what if the straw is not really weird and instead it does fall under the weight of gravity? It would be slightly diagonal, right? So something like that. So I want to draw to your attention the idea that perhaps we might want to know this diagonal height here. Should we try and get rid of the other stuff? Be a tragedy if the actual line went. So if we look at that, it could fall down there, right? Be very interested to see if we could do something with that and figure out if it's a possibility. So you've got to try and imagine here. This is what I thought might be missing in the exam, is you may have done 2D stuff, but maybe not visualizing it in 3D. So what have we got to aid us here? We've got the fact that this width here is 2 times 3.98. And a calculator is to hand, says that it's 7.96. We've got a right angle triangle. And although we don't know where this 18 is going to land, if we did find this hypotenuse, and we could compare it to 18, for sure this would be a longer than the h. I wonder if it's long enough. So let's see. We've got a height here already, haven't we, of 15.4931, etc. So if we put that all into an equation, we've got x, which is the diagonal, is equal to the square root. This is Pythagoras, by the way, so I'm sort of skipping and stepping away that I can set it up quickly. So it's square root. How do I know that? Well, this is the small side and this is the small side. So in that case, we're going to square them and add them together, and it will be equal to the x squared. But if instead we square root them, we've already rearranged it, so x is on its own, right? So that's going to be the 15.4931, which remember is still on our calculator, if we kept it there, so we can dot that. plus the square root of 7.96. That's fairly straightforward. All squared. Okay, press equals 17.4183. It goes on and on and on. Oh darn. Well, that's a shame. You see what it means? This is less than 18. Sadly, at its absolute maximum, which is this diagonal here, it's not long enough. That diagonal is not long enough. We need a little bit more water in there, as 18 is still too big. What I'm going to say for a bonus, for an extra Brucey bonus question, if you're interested in doing it, I would like you to find the amount that the straw comes out of the water. So you imagine that you've got the edge. That's awful. You imagine I'm going to do it from side on. You imagine you've got your straw like this, and clearly 18 is bigger. I want to know this height here. We'll call it M. So what is this height here that it comes out of the water? So there's your bonus, and if you subscribe to Patreon, then I'll have the answer to that in the in the upload, and I will send you, if you do that question for real, if you do give me the answer to that question and you're a member on Patreon, I'll send you out free merchandise. A word, man of my word. Okay, let's go down. Let's do our next one. Oh, we've been an hour. Just to let you know, we've been an hour. We'll try and get through as many as we can. There's still quite a few. This one is one that I thought it hasn't come up yet. So I did a box plot in the previous live. I recommend you go and watch that because I went into detail. Okay, I really put down, what all of it means, and how to draw one, how to calculate interquartile range. This time it's different. This is how to read it and how to compare. And if you look at these two box plots, there's a lot of information and there's a lot of things that you could automatically say just because you think, it looks obvious. For example, group A, look at the difference between the largest and smallest. And straight away I cringe because you can't use the smallest and largest in comparisons. It looks like it's going to beat group B in terms of spread, but in fact we only look at the center point, the interquartile range, and you can see that although it might not feel like it, group B is more spread out because we only look at this center box. So if you haven't seen the previous live on the box plots, go and watch that first if you're not too comfortable, and then come back to this one. Group A and B take part in a memory recall test. The participants from both groups are given a number of objects to remember, and the amount of time it takes to recall them is, let's recall them all by the way, is measured in seconds. The distributions for both groups are shown in the box plots above. Okay, so we've got our thoughts about that. Let's get into it. By comparing the results of both groups, state which group did better. Better. It's very interesting. First, let's establish this. Which group did better in a memory recall test? So if you're taking longer to recall it, that's worse. So we want the groups that are lower down, right? And I'm pointing at this one because I can straight away see that this is the median, this is the median, and we have a lower median. Later on in your statistical career, you might ask yourself, is that significant enough to be classed as different? Because the issue here is that it's not that far away. And given how many, we don't know how many took part, if there were only 10 participants, that doesn't show much evidence to say that they're actually different, because if we did get more participants, it might start moving up here, and it might end up being fairly similar. You don't know. You know what you don't know is a very scary realm of infinity. There's so much. We've got to cling to the few little bits that we do know and stay open-minded. change as much as we can to new information that's presented to us. Open-mindedness, after all, is a very important trait, in my opinion. Always opinions, guys. Group A, just looking at the median, seems to do better. So what we would say, what you do to get your full marks here is make a comparison with values, and then you interpret that. So we're going to say the median of A is equal to 54, and or you could write it like this: the median of B equals 60. And then you could say group A are, which groups did better? We'll not say are then. We'll say group A did better on this measure. Just to be absolutely sure, you could say 54 is less than 60. And that's actually, see, that's the subtle thing about this. It doesn't tell you that, like, if you've got a memory recall test, that actually lower is better. So you have to be aware of the situation and try and immerse yourself in the situation, I guess. So why did I go for median? Well, it's the most important thing to compare. It's a central measure of central tendency and a really easy go-to comparison, right? There are a number of ones that I could compare, like the maximum and minimum. That's not going to count. I could compare the range. That's not going to count. How did I find this value? Well, I went down here on the scale, and I realized I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different steps between 15. So 15 steps divided by, for 15 as a number divided by 10 steps is 1.5. So each of these is 1.5 little squares. So I'd like to think in every 2 is 3. All right, so it's probably an easier way of counting. Okay, so reading that scale is another skill, obviously, you need to be aware of. But aside from that, we compare the median there. The other comparison that counts here is skew. We haven't talked about skew in as much detail. You can get away with a lot here, unless it's perfectly in the middle. Even the slight here, we don't talk about significant skew, we just say that it's skewed, and you can get away with that. So the skew to like the whole distribution, we're not looking where is this box in comparison to the whiskers. We're just looking at where this line is compared to the quartiles. And we can see that if it's slightly to the right, which it is here, it's not called a positive skew. That's called a negative skew. Okay, you think it's positive because it goes to the right, but no. And down here would be a positive skew. So you could say that it's got a slight negative skew. That's an important measure. You can see where it's tending towards, if there's a bias away from the center. Okay, because if it's nicely and normally distributed, it will be right centraled. So the slight negative skew, and you can compare that with this one. So if you're only looking at the box, and there's the middle, we can see this one has a positive skew. So you can use skew, but I really don't think that that is a fantastic measure at the lower levels. I think the better one is the interquartile range, right? So to calculate the interquartile range, we're going to have to need values. So this is going to be 48 interquartile range here, and then 57. So total, we've got an interquartile range. I did this one earlier, so I'm just going to write it down, and you can double check if you agree with me or not. Interquartile range of A is 9, and the interquartile range of B is equal to 30. Ridiculous. See, it's bigger. It's clearly bigger. What does it mean? It's how spread out they are, right? So what could we conclude? We can say that group A, again, has a smaller interquartile range. Therefore, and this is an interpretation, they are more reliable. If you were to randomly pick somebody from group A, you would do better on guessing what score they're going to get because they're consistently around here than if a random person was to be selected from group B and they're so spread out, your one guess could be very far away from where the random person is picked, or where that falls, where they are. So reliability is one good reason for having a small spread, a small range. If you're going to compare the ranges of the two, it's not a good measure. I would definitely avoid that. These are the two strongest measures that you can use to compare in the exam, and the other one is going to be with skew, but probably stick away from that one. It's a little bit more complex. Okay, so not sure what's up with this live chat. Is it working? I just don't know. I'm just going to type something here and see if it comes out. That won't work. Hello, everyone. Has that come through? Okay, it probably is. All right, let's keep going. So there's your box plots, and they're quite important. They haven't come up yet. I don't see why they would miss box plots. Super good. There's an opportunity for box plots to come up with cumulative frequencies, by the way, because cumulative frequency is very easy to draw based on a box plot. This one would be quite drawn out and then go up very quickly there like that. This one would take its time going up and then be something like that. So considering that you could find them quite easily from cumulative frequency, I always think that they should put them in with that, but they don't always. Okay. What question do we want to do? I want to finish on... These are the ones I think we haven't done. I don't know. I'm going to do one more. I'm going to make it this one. Complete the square. 'Cause not many people here, so I can leave the rest for Patreon with the full solutions, and people that want to watch the live replay. It's not necessary to be here for the live. I love the idea, but I'm still making videos here that you can come back to time and time again. So let's make this the last one, and then the video won't be too long. Hopefully it's more like a podcast, right? So you can sort of be in the background and do something else at the same time, like, I don't even know, on the bus. Let's go. Question 26. They won't ask you to solve in a calculator paper, probably, using complete the square. And I also don't think that they would ask you to find the minimum, because the calculator also does that. So my thinking is that it's something like put it into a particular form. Unless this is part A and then part B is worth 1 mark, or it's a real life scenario, whatever. But it's a bit odd, this one, you see. Put it in this form. It's crucial, and you can see my quadratic equations videos. It's crucial that you recognize this form as completing the square. Okay. I don't know how you can get away with an exam series where you don't complete the square. But if this calculator thing that comes, it's probably going to be avoiding to solve. So the first things first, to do this, it's not in a very nice it's not a very nice format. And the first thing is to expand everything and get it to the point. So 3x squared, subtract that thing, and finally, right, not very nice. Not a very nice looking thing. So 2x squared minus 2x minus 1 is, it's not ideal for complete the square, but we're going to do it anyway. Where we have something in front here, we're going to factorize out. So x squared subtract x, and now we can complete the square. So I always open a square bracket so I can separate from the bracket that's on the inside, and we're going to be taking away wait, have I missed this here? No, that's right. We're going to be taking away half of what's in front of this one, and that's 1, right? So that's going to be x minus a half squared, and we immediately take away whatever this is squared, which is a quarter. And don't forget the -1. So it's all going on. Okay, we've got the correct format now, factorizing, and then the completing the square has happened to just the brackets part. And the last thing is to expand in. So expanding that 2 in, it's going to go in front of the bracket, like so. And we're going to subtract a half. So it's 2 lots of a quarter. And then to finalize, take away 3/2. So basically we're looking at what these letters are. A equals 2, B equals a half, and C equals -3/2. So that's probably the hardest question you could get on complete the square, unless you count a real life situation. But they typically don't ask you to complete the square. They don't force you to complete the square in the real life scenarios, any old scenario that is. Complete the square is really useful for when we're trying to find a minimum point, right? So if we look at this quadratic here, if I expand that, that's going to be a positive quadratic. So we're looking at a quadratic something like this, and you want to find the minimum point as a coordinate. You'll find the x here, and you do the opposite sign, and the y is here, -3/2. This is really useful for roughly where it's going to be plotted, right? It's going to be plotted there. And you could see values at the minimum. So it could be useful. Known as the minimum point, because if it's describing a process, this is where you're going to get the smallest output when x is a half. So it could be useful for that reason. Okay, that's it. I'm not going to do the other questions because of time, and probably everyone's very busy, but I'll leave them all up on Patreon, and wishing you the best of luck through the exams. If you're watching this and you found it useful, let me know in the comments. I always like to hear feedback, and it really helps motivate me for what to do next. All I'm looking to do is help with anything you need, and just let me know. I can do that. See you in the next one.